What's up, seventh grade math? How's it going? It has been such a long time since I've made one of these videos, but I am, in case you can't tell, getting all ready for Christmas. It is my favorite time of year. I love wearing this silly hat and other Christmas clothing, which you'll probably see me wearing throughout the season. But we are moving on to our brand new book and a brand new chapter. So, in your brand new book that you all wrote your name in, so you don't lose it, we are going to be on page 233. So go to page 233 in your brand new book. And we're going to look in this section, in this chapter, you are going to be able to use your calculators, because we've already went over how to do the adding and subtracting. So now you're going to be adding and subtracting again in this chapter and multiplying. But in this case, it's not just numbers, but algebraic expressions. So first of all, when an addition or subtraction sign separates an algebraic expression into parts, so only with addition and subtraction, then each part is called a term. And like terms, you'll see this phrase a lot in algebra, pre-algebra, algebra 2. Like terms contain the same variables to the same powers. For instance, 3x squared and negative 7x squared are like terms because they both have x to the second power. So it doesn't matter what the numbers in front are, as long as they have the same variable, x, to the same power, 2, then those are considered like terms. These are not like terms because they don't have the same exponent. Now, the numerical factor of a term that contains a variable is called the coefficient of the variable. So these are a lot of terms that you need to be familiar with because you're going to be using them a lot in all of your math classes that come after this. So for instance, 3x squared is a term. 3 is what we call the coefficient of the term. A term without a variable is called a constant. So if it was just the number 3 and there was no x with it, then we call that a constant. And if two terms are constants, they are also like terms. So let's just look at a few examples of terms, like terms, and constants. So in this case, we have 3 terms. Terms are separated by addition or subtraction. So this is a term, this is a term, and this is a term. Then like terms would be these two because they both have x to the first power. And this number 12, it doesn't have a variable. That is what we call a constant. And you guys can go to page 234 and fill in the boxes here. So we're going to drag like terms. So this is a 4x squared. So what else is a like term to this? Well, here's a negative 9x squared and a 30x squared. This one is a negative 2x. So 6x, 8x, and negative 1.5x because they have x to the first power. And then these are all constants, so these are also like terms. So knowing what are like terms is the first part of this section. You need to know what like terms are because the next thing that we are going to do is combine like terms. So on page 234, an algebraic expression is in simplest form if it has no like terms and no parentheses. So you guys can watch this video quickly.
You can simplify an algebraic expression by combining like terms. First, rewrite each subtraction as addition by adding the opposite. Then apply the commutative property to change the order of the terms. Change the order so that like terms are next to each other. Next, apply the distributive property to the like terms with variables. Now simplify. Add within the brackets to find the coefficient of the variable term. Then add the constant terms. The expression is now simplified.
Okay, so we're going to look at a few different examples of combining like terms. And you don't have to write as many steps as they showed in the video, so we'll look at this. So first of all, the cost of a jacket J after a 5% markup can be represented by the expression J plus 0.05J. So we want to combine like terms and simplify this. So I have a J plus 0.05J. Are these like terms? Well, they both have J to the first power. Remember, even though it's not written, there's always an exponent of 1 there. So these are like terms. So all we have to do to combine these is add the numbers in front of the J's. And remember that even though it's just a J, it's really the same as 1J. So we would add 1 plus 0.05 to get 1 plus 0.05J. So increasing a jacket's price by 5% is the same as multiplying it by 1.05. Let's look at another example similar to this one. This one's not in your book, but the cost of a new fitness tracker C after a 6% markup can be represented by the expression C plus 0.06C. So again, that's like a 1C plus 0.06C. And since these are like terms, we can combine them by just adding these numbers in front. So 1 plus 0.06 is 1.06C. And that's all you have to do for that. So you guys pause the video and try the check problem at the top of page. Okay, so I think I didn't start hitting record again after you guys were supposed to pause and do that check problem. So anyway, I'm going to go back, and sorry if this is a repeat, but look at example 2 on page 235. So I have an expression here that has 5 terms, and terms are separated by addition and subtraction. And we are going to combine like terms. Again, like terms, this one doesn't have a like term, but y and negative 5y and 6 and negative 3 are like terms. So the first thing we're going to do, though, is change all the subtraction to addition. So we're going to make this all addition. So this, instead of minus 5y, it would be plus negative 5y. And instead of minus 3, this would be plus negative 3. And then we are going to simply rearrange this. So the order, if we're adding a bunch of stuff, we can add these in any order. So I'm going to put the y's next to each other and the constants next to each other. And then we can combine things that are the same. There's nothing that's the same as the negative 5x, so we'll just bring that down. But 1y plus negative 5y, so 1 plus negative 5, a positive plus a negative, we subtract those to get negative 4y. And then 6 plus negative 3 is just 3. And because parentheses are in the expression, it's not simplified. So simplified in simplest form means there are no like terms and no parentheses. So what we're going to do now is change this back to a subtraction problem. And this is our expression in simplest form. It's just negative 5x minus 4y plus 3. We cannot combine any more of these. None of these are like terms. So this expression, simplified, would become this right here. Let's look at another example because this can get a little bit confusing. This one is not in your book. I want you guys to write this down in the margins on page 235. So I'm going to be looking for this problem in the margins of page 235. So take a minute and copy this problem down. If you need to pause to do that, you can do that, but I'm going to keep going here. And what we're going to do is combine like terms. So first of all, we have a 3a and a 2a. Those are like terms. And if you want, you really don't have to rewrite all this. So I'm going to show you one example where we can do this without maybe rewriting everything, okay? And that is 5a. So when we combine like terms, another way to do this without rewriting it as subtraction is just when you're combining like terms, think of it as adding those two terms together. And then I also have like terms with a b. So this is a positive 6b and a negative 8b. If I'm going to add these two together, 6b plus negative 8b. 6 plus negative 8 is negative 2b. So that's another way you can do this without having to rewrite each one. And then I have negative 4 plus negative 9. So when we're combining like terms, we're adding these like terms together. Negative 4 plus negative 9 is negative 13. So which answer choice is that? 5A minus 2B minus 13 is going to be our answer here. So excuse me, I would like you guys to try the check problem at the bottom of page 235. So pause the video now and you guys try that check problem right there. Okay, so then turn to page 236 for our last problem for this video, and we're going to combine like terms, but you can see that our terms have fractions in them. So this kind of combines what we did last chapter with the new stuff we're going to be doing in this chapter with simplifying expressions. So if I want to simplify these expressions, I have a like term and a like term. Like term, and we're going to combine these together. So you can follow along on page 236 here. If we were going to rewrite everything as addition, this would be plus negative 2/3 and then plus negative 1/2 a. So again, whatever works for you. If rewriting it is easier, if it's not, and you just want to do what I did and just circle the terms and then add those together, you can do that as well. So whatever makes the most sense and is easiest for you to understand, feel free to do that. So now I'm going to put the a's next to each other and the constants next to each other. And then we just have to, if I want to add 3/4 and negative 1/2, I have to have a common denominator. So if we get a common denominator here and here my common denominator would be 6, and here my common denominator with these two would be 4. And now we can combine those to get 1/4 a plus 1/6 when you add those together. Again, you are able to use calculators. With fractions, it's a little bit more tricky, so we'll work together in class how you can plug those in, but you guys can start practicing that now if you want to. Okay? Let's look at another example like that, because the fractions get a little bit tricky, and this will be our last problem for this video. So again, write this down on page 236 in the margins. Let's write this problem down, and I will be checking to see that you have this one written down as well, because I want to make sure you guys are watching these videos and having everything on there that you need to. So let's look here. First of all, 1/8 is a constant, and there's another constant, positive 3/4. So 1/8 plus 3/4 would be 1/8 plus 6/8 if we got a common denominator, which is 7/8. So automatically, that eliminates 2 of these answer choices. If you're doing a multiple choice test, it is important to understand how to take multiple choice tests as well. Process of elimination means if I don't know how to do the rest of this problem, instead of having a 1 in 4 chance of guessing correctly, I now have a 1 in 2 chance, a 50% chance of getting the correct answer if I was just guessing because I didn't know how to finish. So learn how to become smart test takers as well, because that's an important skill to have. Now, negative 1/9 x and negative 2/3 x. I'm going to add negative 1/9, plus negative 2/3, which is negative 4/9. No, negative 6/9. Sorry, we would multiply by 3/3. And again, we're adding these two terms together. If they're like terms, we're adding them together. So we're adding a negative 1/9 plus a negative 2/3. So negative 1/9 plus negative 6/9. A negative plus a negative, I add those to get negative 7/9. So this would be negative 7/9 x. So our correct answer here is answer choice A. So now you guys pause and do the check problem in the middle of page 236. We'll check that answer together in class tomorrow. But in the box at the bottom of page 236, don't forget that you need to get your parents to check pages 235, 233, 234 really, to 236, and have them sign in the box that they've seen pages 234 to 236, that you have all your notes, and I will be checking page 236 for their signature along with the other problems I told you to write down to make sure that you watched this video and took the appropriate notes. All right, talk to you next time.